Okay, now let's go over some examples where we're going to have to use this product to a power property. All right, so this first question just says, which expression represents the area of the square? And here you can see we're given a square with a side length of 5x cubed. So for this, we need to remember that the area of a square is equal to just one side squared, right? Length times width. They both have the same side, so we can just say that it's equal to one side length squared. So now we know that a side length is equal to 5x to the third, so we can say that 5x to the third squared will be the area of our square. So now remember, we have a product being raised to a power, so we have to raise each of these factors to that power of 2. So that gives us 5 squared times x cubed squared. And if we go ahead and simplify, 5 squared is 25, and we use that power to a power rule here. X to the third being squared, we multiply the exponents. That gives us x to the sixth. So you can see our answer here would be D, 25x to the sixth. Now let's take a look at a couple more. Here we have negative 2k to the fifth power. So same thing, product to a power, we have to raise each of these factors to this power of 5. So here we have negative 2 to the fifth power. Notice that this negative sign is inside the parentheses. This is times k to the fifth power. And now we just have to simplify. Well, negative 2 to the fifth power, remember a negative number raised to an odd exponent is going to be negative. So this will give us a negative 32k to the fifth. Now once you go ahead, pause the video, try the second one on your own using that power or product to a power rule. All right, now let's go over it. We have negative 3x squared y to the fifth, and this is all being raised to the third power. So product to a power rule, we raise each factor in here to that power of 3. So we do that, and this gives us negative 3 cubed times x squared cubed times y to the fifth cubed. And now we can just go ahead and simplify. So negative 3 to the third power, negative 3 times negative 3 times negative 3, that's going to give us a negative 27. Now we have x squared all being cubed. We use our power to a power rule, multiply these exponents. That gives us x to the sixth. And lastly, we do the same thing. We raise a power to a power, so we multiply these exponents. This is y to the 5 times 3, which is just y to the 15th. And there we go, our final answer, 27 x to the 6th, y to the 15th. Now let's take a look at this one more. We have n to the 1/2 to the 10th power times 4mn to the negative 2/3 power, all being raised to the third power. So this one may look a little bit tougher, but all throughout we're using our power properties here, all right, our exponent properties. So this first one, n to the 1/2 to the 10th power, we just have to do this power to a power rule. This is n to the 1/2 times 10. 1/2 times 10, well, that's equal to n to the 10 over 2, and that's equal to n to the 5th power. Now for here, right, we have to use our product to a power rule, right? All of this is being raised to the third power, so each factor in this set of parentheses has to be raised to the third power. So we do that, and this will give us 4 to the third power times m to the third power times n to the negative 2/3 times 3. All right, and now if we simplify this right here, that would give us n to the negative 2 power. And now from here, we can just simplify and then multiply our powers that have the same base. So 4 to the third power, that is just going to give us 64. And then we have our n's. So n to the fifth power times n to the negative second power. Remember, powers of the same base, we have to add our exponents. So 5 plus a negative 2, that gives us 3. So this is going to be n to the third, and then our m cubed. We don't have any powers of the same base with this m cubed, so we're just going to leave it like that. M cubed. And here's our final answer, 64 n to the third, m to the third.